Okay, so this problem is from chapter 5, and it's a determine whether the two pairs of numbers are proportional. And the pairs of numbers are 2.8 and 6, and 2.1 and 4.5. And so this is one where they want to know, are they proportional? Let me just make a note here. Are they proportional? All right, and so what does this mean? Well, let's just look at the pad just for a couple of minutes here, and we'll knock this one out pretty quick, I think. Remember that the idea is that these are written as pairs of values that are in some relationship to each other, and we're trying to compare these quantities. So remember we said that we have ratios where we compare quantities. So this is comparing 2.8 to 6. And this is comparing 2.1 to 4.5, or we could say 2.8 colon 6, 2.1 colon 4.5. Right? Those are the two ways we could write it. The third way is the way that we'll use, which is the fraction notation way, which is 2.8 over 6 and 2.1 over 4.5. All right. And the question is, are these things equivalent amounts? Are they equivalent amounts? You say, what do you mean by that? I know that 2.8 does not equal 2.1, yeah, and I know that 6 does not equal to 4.5. But does the relationship of 2.8 to 6 equal the same relationship as 2.1 to 4.5? And you're saying, I don't know what you're asking me. Well, if you had 6 objects, and maybe hard to visualize, but just think with me now. If you had 6 objects and 2 8/10 of them were a certain shape, okay, and then you also had 4.5 objects and 2 1/10 of them were a certain shape, would that do you any good? Does that help you to kind of visualize what we're doing here? So if you say, no, that didn't help me a bit. Well, if you think about this in maybe a slightly different way, what if we say to ourselves, I might could understand this a little better. I might could understand this just a little better if I could get rid of those decimals and get whole numbers. Sure, I can do that. I can multiply this times 10, and this times 10, this times 10, and this times 10, and you say, well, you're going to change the numbers entirely. Well, I'm only going to do this for your mental comparison purposes. All right. Now, this might be easier for you to visualize. This might be easier for you to visualize. If you had 60 objects and 28 of them were a certain shape or size, you'd say, yeah, 28 out of 60, yeah, that's about half of them. And you look over in the other group of objects, you had 45 of them, and they were a certain size or shape, and you'd say, yeah, that's about half of them, okay? And you say, yeah, I'm thinking maybe these are, but I don't know for sure, okay? So sometimes if you can convert just decimal ratios to equivalent ratios without decimals, your visualization helps, but you don't have to. Now, you say, well, let's get on and solve this problem. You ready? So here's how we're going to solve this problem. The question is, are these things proportional? And what we're going to do is we're going to use the idea of cross products. Cross products. And what are cross products? Well, cross products simply say multiply like this and multiply like this. And if the cross products are equal, then we do have a proportion. We say if we have equal cross products, we have a proportion. You say, okay, well, let's get on with it. All right, 6 times 2.1 is 12.6. Okay, that was easy. All right, what about 2.8, 5 times 4.5? 5 eighths is 40. Okay, so that's 6 times 2.1, yeah. And do I have this right? 2.8 to 6, 2.1 to 4.5. Okay, 8 fives is 40. Yeah. 5 eighths are 40 rather. 5 times 2 is 10 is 14. 4 times 8 is 32. 4 times 2 is 8 and carry the 3 and I get 11. I get 0, 6, 2, 1 and I got to count off 2 places. Okay, son of a gun, I got 12.6 both times. Okay, so what does that tell you? What does that tell you? Well, it tells you that, oh, and you say, wait a minute, now stop, hold it. You got 12.60 here. Okay, if you kind of remember back with decimals, I could stick a 0 here and it would not change anything other than I'm just filling in blank spaces here. If I have a 0 down here, I don't have anything here, so I could think of that as 12.6. So they're both 12.6. Hey, so what does that mean? It means the cross products were equal. Therefore, it means, yes, we do have an equivalent relationship, and so therefore we have a proportion. All right, let's see if Math Excel agrees with us. And does it agree with us? I don't know. We'll see. One-time shot here. Very nice. Okay, so Math Excel liked it. All righty, so let's end this video.